Day 454 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 898, bitwise ORs of subarrays. The difficulty level is medium, but don't worry because you already know we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, subscribe, and share. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given an integer array R, return the number of distinct bitwise ORs of all the non-empty subarrays of R. The bitwise OR of a subarray is the bitwise OR of each integer in the subarray. The bitwise OR of a subarray of one integer is that integer. A subarray is a contiguous non-empty sequence of elements within an array. All right, y'all, so that may seem a little bit confusing at first, so let's go ahead and take a look at these examples just to make sure that we are doing this problem correctly. So in example 1, we have our input R equals an array of integers, and that integer is 0. Output is 1. Explanation says there's only one possible result, 0. So our output is 1. Now, this example really doesn't make any sense, or it makes sense, but this example may be a little bit confusing as well. But what it's saying is, since there's only one unique element when we do our bitwise OR, so when we do our bitwise OR on 0, it says the bitwise OR of a subarray of one integer is that integer. So the bitwise OR of 0 is 0, right? And since the bitwise OR of 0 is 0, 0 is the only unique element, meaning there's only one unique element. And since there's only one unique element, our output is 1 because we're counting the number of distinct elements or unique elements. So let's take a look at example 2. Example 2 might make sense a little bit more because I understand that might still be a little bit confusing. And I'll go through example 2 a little bit more in depth. So example 2, we have our input R equals an array of integers 1, 1, and 2. This time our output is 3. Explanation says the possible subarrays are 1, 1, 2, 1, 1, 1 and 2, and 1, 1 and 2. These yield the results 1, 1, 2, 1, 3, and 3. There are 3 unique values, so the answer is 3. Okay, so let's break this example down one step further. So we have our array of integers 1, 1, and 2, right? The possible subarrays are 1, 1, 2, 1 and 1, 1 and 2, and 1, 1 and 2. So let's break down these subarrays, right? So and turn them into binary so we can see what's going on, right? So, well, the first thing we want to know is, given the integer R, return the number of distinct bitwise ORs of all the non-empty subarrays, but is the bitwise OR of a subarray is the bitwise OR of each integer in the subarray. So these are just the bitwise, these are the subarrays right here, right? And these are all of the subarrays that we can create with this array right here. Now, we're not done yet because we have to do more than convert them into subarrays. We have to compare them using the bitwise OR. So first, let's just go through this. So when we do 1, 1 in binary would be 0, 0. Let's see, will be 0, 0, 1. So we have 0, 0, 1. Then we have another 1. So that'd be 1. That equals 0, 0, 1 as well. Then we have a 2. 2 in binary would be 0, 1, 0. So that's, oh, sorry, y'all, 0, 1, 0. That's 2 in binary. Then we have the 1, 1s. Okay, so we can get rid of this. We just need these two right here. So we have the 1s. We just have 1s and 2. Now we have to get the bitwise OR of each of these subarrays, right? So first bitwise OR is just 1, right? So it says right here, once again, the bitwise OR of a subarray of one integer is that integer. So first subarray, right, is just 1. Boom. So we put 1, that's going to be 0, 0, 1. Boom. That's the first subarray. Second subarray, same thing. 1, 0, 0, 1. Boom. Third subarray would be 2. So 2 is going to be 0, 1, 0. Boom. Next subarray is 1 and 1. So now we have to actually compare some elements. So 1, let's see how I'm going to do this. 1, we're going to compare them by saying 001, come back, 100, sorry, 1 equals 001. And now we're going to compare them. So when we compare them with the bitwise ORs, if there's a 1 or a 0, when we compare a 1 or we compare a 0 and 1, so we compare two ones, that's going to be a 1. If we compare a 0 and 1, that's going to be a 1 as well. But since there's only the 1, since this is the only one with the 1, everything else is going to be 0. So we could put this right here. We could say equals. So the bitwise OR, this represents the bitwise OR. The bitwise OR of these two, which we could, let me come up here so y'all can see which subarray we're on. So this subarray, yeah, let's do it like that so it can make sense, y'all. So this would be 1, then this would be 1, and this would be 2. Boom. So now let's clean this up a little bit. Okay, so now we're on this subarray right here. Boom. So the bitwise OR of this, when we compare the two ones, that's going to be a 1. If it would have been a 1 and 0 or 0 and 1, it'd be a 1. But since these are zeros, it's going to be 0, 0, 1. So the bitwise OR of this is 1. Boom. And then after this, now we're right here, finding the bitwise OR of 1 and 2. So for that, we could just, come right here, 1, 2, that's what we're on. So 1 is going to equal 001, and 2, sorry y'all, 2 is going to equal 010. The bitwise OR of those is going to equal. So once again, we're going to compare. So for these two, we're comparing a 0. For these bits, is a 0 and a 0. So that's going to be a 0. This is 0, 1. So that's going to be a 1. And this is 1 and 0. So that's going to be a 1. So this output would be 3. 011 is 3 in binary. So we could just come over here and say that equals 3. This equals 1. This equals 2. Yeah, we got that. So hold on, y'all. Let me just make sure that we are on track. So we have this right here would be 1. This right here would be 1. This right here would be 2. This right here would be 1. And this right here would be 3. So yep, that's right. We're on track. Boom. So now we're doing this one right here, the last one. Boom. So let's come right here, open up the or put the subarray, and boom. So now we're comparing 1, 1, and 2. So first 1, once again, that's going to be 001. Then we're doing another 1, so that's going to be 1. That's going to be 001 again. And then we're going to do the 2, so the 2 is going to be 010. Boom. Now, when we compare three numbers like this, first it would look something like this. So we're going to do 1 or 1. So the parentheses, PEMDAS, remember we do the parentheses first, and then we do the 2 after we already have done these 2 ones that are in the parentheses. So this would be, we're going to come down here for this last one since it's 3. So this would be 001. Then we're going to say 001. We're going to compare these. When we compare these, we get 001. So we get 1 again. Boom. So now we take this one that we just got from these 2 ones right here. Now we take this one and we do the OR. We can do the bitwise OR with the 1. So it'd be 010 that we got from this. And then now we get 011, which is equal to 3. Boom. So that's how we got this 3 right here. So now we come right here. So we got 1, 1, 2, hold on, 2. It's all right here. 1, 1, 2. Then we got 1 again. Then we got 3. So out of these 3 elements, or excuse me, we could just copy and paste this. So not 3 elements, but out of all of these elements, there are 3 distinct or unique values, right? So we have, meaning there are 3 different numbers in these numbers, right? We have a 1. Sorry, y'all. We have a 1, we have 2s, and we have a 3. These are the 3 numbers that appear in these numbers right here, or these results, right? These are all of the results that we got from these bitwise ORs, right? So out of these results, we only have 3 different numbers, 1, 2, and 3. So since we only have these 3 different numbers, those are our unique elements, right? So since there are only 3 unique elements, that's why our output is 3, and that's how we got it. Now, I'm not going to go through example 3 all the way and break it down like this. I encourage y'all to do it yourselves so y'all can see how it works. You know, got to give out homework every now and then in class, right? So this is like y'all homework where y'all can practice and do it yourselves. But just know these are the values you should get. And once you get these values, you'll see that there are 6 unique values. 1, 2, 3, 4, 5, and 6. So these are the 6 unique values. You may get more than that. It might look something like this, but just these right here represent the unique values right here. So when y'all go through example 3, just make sure you should be getting these unique values right here. It should be 6 of them, right? But we could go through it anyway. The input R is the array of integers 1, 2, and 4. The output is 6. Explanation says the possible results are 1, 2, 3, 4, 6, and 7. And there are 6 unique values, and that's how we got 6. So I hope that makes sense to y'all. And now that we understand the question, let's get into the fun part, the actual solution. Y'all, solution is not that difficult at all. So let's get to it. Now, the first thing we're going to do is we're going to create a set to store all of the unique bitwise OR results from all subarrays. So for that, we're just going to create the variable, call it all ORs, and we're going to set that equal to a set, a less than, and a greater than, and put a parentheses. Then we need another variable to store the set of OR results for subarrays ending at the previous element. So we're going to declare a variable called previous step ORs, and we're going to set that equal to a set of integers as well, just like we did before. So same thing, boom. Now we're going to loop through each number in the array. So we're going to say for num and r, we're going to open up the brackets. And now we're going to create a variable that stores the bitwise OR results for subarrays ending at the current element. So we're going to declare a variable. This is going to be called current ORs. And we're going to set that equal to set that equal to a set of integers again, just like that. Boom. Now we need a subarray containing only the current number has an OR result of num. So we're going to come right here. Oh, sorry, get rid of this 0. We're going to come right here and we'll say current ORs dot insert, open up the parentheses, num. Boom. Then we're going to extend the previous subarray by adding the current number and compute the new OR values. So we're going to say for previous OR in previous ORs, we're going to, it should be capitalize that as well. In previous ORs, we're going to open up the bracket and we're going to say current ORs dot insert, open up the parentheses, num or bitwise or previous or. So it's going to insert the bitwise or of num and previous or, Boom. Then we're going to add all of the current OR results to the global set of all results. So we're going to come underneath this and we are going to say all ORs dot form union, open up the parentheses, current ORs. Then we're going to prepare the next iteration by the current ORs with or will be the previous ones for the next element. So we're going to say previous step ORs equal current ORs. Then finally, we just need to return the number of distinct bitwise OR results from all the subarrays by coming right here and saying return all ORs dot count. Boom. And that's going to get us the count of all of the unique numbers. Sorry about that, y'all. So let's run it, see how it runs. Hopefully it runs proper. Okay, see, we got an error. Cannot find current ORs. Let's make this capital R. Let's run it again. Let's see. Okay, cannot find previous ORs in scope. Now, hold on, y'all. Oh, so this should be previous step ORs. Sorry, y'all. Now let's run that, see if that works. And it's accepted, y'all. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see, and look at that, y'all. 295 milliseconds beats 100% of users. That's what I'm talking about. That's what I like to see. So with that being said, y'all, I hope y'all learned something today, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.